Welcome to the instructional build video for the R1 robot. This video will provide you with comprehensive step-by-step instructions on how to build your very own R1 from the ground up. Be sure to use eye protection and exercise caution when working with tools. Step 1. Take the robo base and rotate it 180 degrees so that the recessed nut holes are facing the top. Step 2. Take 3 M4 nuts and insert them into the front and side nut recess holes on the robo base as shown here. The recess holes are designed for a snug fit, so it may be necessary to use a metal object, such as pliers, to help insert the nuts. Step 3. Take 6 M3 nuts and insert them into the 6 remaining nut recess holes on the robo base as shown here. As before, it may be necessary to use a metal object to help press the nuts into place. Step 4. Take the gear rail and position it above the robo base as seen here. Take 2 M3 nuts and insert them into the nut recess holes on the gear rail, pressing them in as tightly as possible. When complete, we are going to flip the robo base and gear rail over so that the gear rail is positioned underneath the robo base. Step 5. Take 2 M3x8 screws and insert them through the holes on the robo base so that they line up with the M3 nut recess holes on the gear rail. Once they are lined up, insert them through the holes in the robo base and gear rail, screwing them into the M3 nuts of the gear rail and connecting the robo base and gear rail pieces. Step 6. Flip the assembled piece back over 180 degrees so that the gear rail is facing the top. Take the small 10-tooth gear and insert it into the center of the gear rail so that the teeth of the small gear and gear rail mesh together. Step 7. Take the rail slider piece and install it by sliding it onto the gear rail from the side as shown here. Move it into a position where the hole on top of the rail slider is lined up with the hole in the small gear. Step 8. Take the 2.8 BYJ stepper motor and insert the brass shaft through the rail slider hole into the hole in the 10-tooth gear. It may be necessary to pivot the motor to align the shaft with the hole in the 10-tooth gear before inserting it. The shaft hole is designed for a tight fit, so we can put a bit of pressure on the bottom of the motor when inserting the shaft into it. Ensure that the round blue collar of the motor correctly inserts into the hole of the rail slider piece. Step 9. To properly connect the motor to the robo base assembly, the 2 holes on the top of the motor casing need to be correctly aligned with the 2 holes in the rail slider. In order to properly align the motor holes and the rail slider holes, the motor needs to be manually turned. If we try to spin the motor by twisting the metal case, it will spin the 10-tooth gear as well and move the rail slider. To prevent this, we turn the motor while holding the rail slider tightly against the rest of the base assembly to prevent the 10-tooth gear from moving, which will allow us to line the motor holes up. When doing this, we will feel resistance from the motor as we are manually spinning the shaft of the motor during this movement. The motor will only line up in one position and due to this, cannot be incorrectly installed. Step 10. Take the motor mount piece and slide it over the motor until it touches the motor holes. Next, take 2 M3x30 screws and insert them so they go through the motor mount, motor holes, and rail slider holes. If the screws do not slide easily through the holes, it may be necessary to screw them in with the Allen key. Step 11. With the M3x30 screws in place, flip the entire assembly over so that the robo base is on top. Using the 3mm Allen key, push down on the 10-tooth gear by sticking the Allen key through the access hole in the robo base. This will ensure the gear is tightly inserted against the motor shaft. Step 12. Secure the motor and motor mount by holding them tightly and by pushing. Pivot the RoboBase and gear rail over so that the nut recess holes on the top of the rail slider are accessible. Install two M3 nuts into the nut recess holes on the rail slider. The inside hole must be accessed by placing the M3 nut through the access hole in the RoboBase, which can be a bit tricky. It may be necessary to slightly unscrew the M3 by 30 screws in order to insert the M3 nuts. Once the M3 nuts are in place, tighten the M3 by 30 screws so that they screw into the newly installed M3 nuts. The RoboBase and motor assembly are now complete and can now be pivoted to return the RoboBase to the central position. Step 13. Take the base plate and ensure that the positioning of the holes matches what is seen in the video so that it does not get assembled upside down. Step 14. Take the 4 robot feet and place one M3 nut inside the nut recess hole on each of the 4 feet. The nuts are designed to be slightly pressed into this hole so that they do not fall out during installation, which means it may be necessary to use a metal object and some force to fully insert them into the feet. Step 15. Take 4 M3 by 14 screws and insert them through the holes in the base plate so that they screw into the M3 nuts on the feet, connecting the 4 robot feet to the base plate. It may be helpful to install one robot foot at a time. Step 16. Take the rear mount and place it onto the base plate, lining up the 3 holes. Step 17. Take 3 M4 nuts and insert them into the 3 bottom nut recess holes of the rear base mount. Step 18. Take 3 M4 by 10 screws and insert them through the bottom of the base, screwing them into the 3 M4 nuts inside of the rear mount, connecting the rear mount to the base plate. Double-check that the holes on the base plate are in the same position as they are in the video. Step 19. Take the assembled RoboBase and place it so that the 3 motor mount holes line up with the 3 front base plate holes, and the single rear hole on the RoboBase lines up with the top hole of the rear mount. Step 20. Insert 3 M4 nuts into the nut recess holes of the motor mount. Step 21. Take 3 M4 by 10 screws and insert them through the bottom of the base, screwing them into the 3 M4 nuts inside of the motor mount, connecting the motor mount to the base plate. Double-check that the holes on the base plate are in the same position as they are in the video. Step 22. Insert the single M4 lock nut, denoted by increased length and a blue rubber gasket, into the upside-down nut recess hole on the underside of the top of the rear mount. Step 23. Install an M4 by 10. Screw through the hole in back of the RoboBase and top of the rear mount, screwing it into the M4 lock nut. The base plate and RoboBase assembly are now fully connected. Step 24. Take the 2 side brackets and place them so that the holes with the bolt recess are lined up with the 2 holes in the RoboBase that lead to the M4 nuts. Step 25. Install 2 M4 by 8 screws through the holes in the brackets and RoboBase, screwing them into the M4 nuts underneath the base, connecting the side brackets and robo base. Again, ensure the screws are inserted in the bolt recess hole on both side brackets. Step 26. Take the two side projector clamps and place them so that each pair of elongated holes is lined up with the pair of M3 nuts beneath it. Step 27. Take 4 M3x6 screws and install them through the holes in the clamps and robo base, screwing them into the pair of M3 nuts underneath each side clamp. Step 28. Take the front bracket and place it so that the single bolt recess hole lines up with the hole in the robo base, which leads to the final front M4 nut. Step 29. Take one M4x6 screw and install it through the hole in the bracket and robo base, screwing it into the M4 nut underneath the base, connecting the front bracket and robo base. Step 30. Take the rear projector clamp and place it so that each elongated hole is lined up with the M3 nut beneath it. Step 31. Take two M3x4 screws and install them through the elongated clamp holes and holes in the robo base, screwing them into the final pair of M3 nuts beneath them. Step 32. Take the two side posts and align them with the two side brackets. Note the positioning of each side post in relation to the side of the robo base it is being installed on, as denoted by the number and order of M4 nut recess holes in each. Step 33. Insert 5 M4 nuts into the nut recess holes of the side post currently viewed from the position seen in the video. From here on out, this post will be referred to as the computer side post. Step 34. Insert an M4x8 screw through the recess hole on the outside of the side bracket, through the hole in the computer side post, and screw it into the M4 nut opposite its position. Step 35. Insert 3 M4 nuts into the nut recess holes of the opposite side post, to be referred to from here on out as the Arduino side post. Step 36. Similarly to the previous side, insert an M4x8 screw through the recess hole on the outside of the side bracket, through the hole in the Arduino side post, and screw it into the M4 nut opposite its position. Step 37. Take the front post and align it with the front bracket, taking note of the positioning of the holes shown in the video. Step 38. Insert one M4 nut into the nut recess hole on the bottom of the front post. Step 39. Take one M4x6 screw and insert it through the bolt recess hole in the front bracket, through the hole in the front post, and screw it into the M4 nut opposite its position. Step 40. Take the Arduino mounting plate and place it down on a flat surface. Step 41. Take the Arduino and insert it into the shaped recess on the Arduino mounting plate. Due to the design of this recess, the Arduino will only fit in the correct way. Step 42. Take two M2x6 screws and install them through the shown holes in the Arduino, screwing them into the plastic holes on the Arduino mounting plate. Step 43. Take the breadboard and flip it over to remove the sheet covering the adhesive strip. Step 44. With the adhesive strip exposed, install the breadboard onto the Arduino mounting plate in the position shown here, pressing firmly to properly mate the adhesive and the mounting plate. Step 45. Take the small piece of double-sided adhesive tape and stick it onto the Arduino base plate in the position shown here. Step 46. With the top side of the adhesive uncovered, lower the motor driver board onto it in the orientation shown here. As with the breadboard, be sure to press firmly to properly mate the adhesive. Now that the Arduino mounting plate is properly configured, it is time to install it onto the robot. Step 47. Take the Arduino mounting plate and align it inside of the Arduino side post so that the Arduino is facing out. Step 48. insert the 2 pegs of the Arduino mounting plate into the recessed circular holes on the inside of the Arduino side post. Step 49. Take 2 M4 by 25 screws and insert them through the outside holes of the Arduino side post, through the Arduino mounting plate holes, and out the other side. Step 50. Take 2 M4 nuts and install them onto the ends of the 2 M4 by 25 screws that are sticking out of the Arduino mounting plate. Step 51. Moving our attention to the computer side post, take the computer mount and align the 2 holes as shown onto the outside of the computer side post, at the same height as the 2 inner M4 nuts. Step 52. Take 2 M4 by 8 screws and insert them through the recessed bolt holes on the computer mount and computer side post, and screw them into the 2 M4 nuts positioned opposite them. Step 53. Take the robot's computer and insert it into the computer mount, in the same position as shown in the video. An easy way to check is to make sure that the ports on the computer are in the same orientation as they are in the video. Step 54. Take the computer top bracket and align it with the smaller M3-sized hole on the computer side post. Step 55. Insert an M3 nut into the nut recess hole on the front of the computer top bracket. Step 56. Insert an M3 by 10 screw through the outside hole of the computer side post and screw it into the M3 nut of the computer top bracket, securing the computer in place. Step 57. Place the robot's projector onto a flat surface and insert the angled HDMI adapter into the HDMI port on the back of the projector. Step 58. Take the projector and place it on top of the robo base, in the area between the Arduino and computer side posts. When placing the projector into position, it may be necessary to move the side or rear projector clamps if they are positioned too close and prevent the projector from being placed down. When installing the projector, the front of it should sit at a slight angle due to the incline of the front bracket. Once placed on the front bracket incline, the projector should be pushed as far forward as it can go so that it hits the vertical portion of the front bracket. The projector will not make contact with the front post, and if it does, it is not correctly installed. Step 59. Take the projector's power cord and run it through the top and bottom of the rear mount and underneath the robo base. Install the power cord by slightly lifting the projector and using the space to guide the cord into the correct plug. This step can be tricky, so take your time and ensure that the power cord does not accidentally become plugged into the wrong spot. Step 60. Take the rear crossmember and align it so that it sits between the 2 side posts. The correct positioning of the crossmember will have the recessed nut holes facing the front of the robot. Installing the head frame can be tricky, as it is necessary to simultaneously hold the rear crossmember and head frame piece at the same time while driving the screw through. While these instructions are a guide to installing in practice, you may find a way that better suits your build style. Step 61. Take one of the head frame pieces and place it on the outside of the computer side post, so that the bolt holes of the head frame and post are lined up. The head frame pieces are identical and therefore can be used on either side. Step 62. Insert 2 M4 nuts into the nut recess holes on the computer side of the rear crossmember. Step 63. Take 2 M4 by 20 screws and insert them through the holes of the head frame, side post, and rear crossmember simultaneously, screwing them into the M4 nuts opposite them. Step 64. Take the other head frame piece and place it on the outside of the Arduino side post, so that the bolt holes of the head frame and post are lined up. Step 65. Insert 2 M4 nuts into the open nut recess holes of the rear crossmember. Step 66. Take 2 M4 by 20 screws and insert them through the holes of the head frame, side post, and rear crossmember simultaneously, screwing them into the M4 nuts opposite them. Step 67. Take the front crossmember and align it to achieve the following. The recessed nut hole is pointing towards the front of the robot, and the side holes are aligned with the holes on either side of the head frame. The front crossmember should be placed in between the two head frame pieces. Step 68. Insert an M4 nut into the recessed nut hole on the front of the front crossmember. Step 69. Install an M4x8 screw through the top recessed bolt hole of the front post and screw it into the M4 nut opposite it on the front crossmember. Step 70. Insert two M4 nuts into the recessed nut holes opposite of each other on the sides of the front crossmember. Step 71. Install two M4x14 screws through the outside holes of the head frame and into the holes of the front crossmember, screwing each into the M4 nut inserted in the front crossmember. Step 72. Insert two M3 nuts into the two recessed nut holes on top of the front crossmember. Step 73. Take a black spacer and one of the sound level sensors and position them underneath the front crossmember M3 hole as shown in the video. Step 74. Install an M3x20 screw through the bottom of the sound sensor, spacer and M3 hole of the crossmember, and screw it into the M3 nut above it. Step 75. Take the other black spacer and sound level sensor and again align them with the M3 hole on the opposite side of the front crossmember. Step 76. Install an M3x20 screw through the bottom of the sound sensor, spacer and M3 hole of the crossmember and screw it into the M3 nut above it. Step 77. Shifting focus once again to the rear crossmember, insert two M3 nuts into the recessed nut holes of the rear crossmember facing the front of the robot. Step 78. Take the top projector clamp and position it on the back of the rear crossmember so that the elongated bolt holes line up with the M3 nuts behind them. Step 79. Install two M3x8 screws through the elongated bolt holes and rear crossmember holes, screwing them into the M3 nuts of the rear crossmember, just enough to have them secured. Step 80. Lower the top projector clamp down on top of the projector so that when tightened in place, it will put a slight downwards pressure on the projector. Step 81. Fully tighten the M3x8 screws to secure the position of the top projector clamp. We are now going to shift focus to the installation of the robot's mirrors. The top mirror is the shorter one while the rear mirror is the longer one. Step 82. Take the rear mirror bezel and place it down onto a flat surface. Although both sides of the mirrors shown in the video are reflective, the mirrors we use on our robot will only be reflective on one side. The reflective side of either mirror will be placed face down into the mirror bezel, and the non-reflective side will be facing up towards the mirror bridge. Step 83. Take the rear mirror, which is the larger of the two mirrors. Remove any protective film and place it down into the recess of the bezel so that it sits flush with the back sides of the bezel. Step 84. Take the rear mirror bridge and place it down onto the back of the mirror so that the ends of it line up with the raised portions of the bezel. Step 85. Insert four M4 nuts into the nut recess holes of the rear mirror bridge. Step 86. Insert one M4 nut into the top nut recess hole of the raised semicircle portion of the rear mirror bridge. Step 87. Install four M4x14 screws into the recessed bolt holes of the mirror bezel, through the holes in the rear mirror bridge, and screw them into the recessed M4 nuts opposite them. This will connect the mirror bezel to the mirror bridge. Step 88. Take the rear mirror support and install it in the same orientation as shown in the video. The support goes in between the two head frame pieces, and the holes leading to the mirror support nut recesses should be aligned with the holes on either side of the frame. The computer side of the mirror support has an additional section and nut recess hole that lines up with the adjustment slot on the head frame. Step 89. Insert two M4 nuts into the nut recess holes of the rear mirror support. Step 90. Install two M4x8 screws through the outside holes of the head frame into the nut recess holes of the rear mirror support and screw them into the M4 nuts opposite them. Step 91. Pivot the rear mirror support so that the bottom adjustment slot in the center of it is facing forward at a 90-degree angle. Step 92. Take the rear mirror assembly and place the semicircle part of the rear mirror bridge into the semicircle-shaped opening in the center of the rear mirror support, so that the longer end of the mirror bridge faces the front of the robot. Step 93. Install an M4x20 screw through the bottom adjustment slot of the rear mirror support, through the M4 hole of the rear mirror bridge semicircle, and screw it into the M4 nut opposite it. With this screw loosened, side-to-side adjustment of the rear mirror is possible. Step 94. Insert one M4 nut into the third nut recess hole in the back computer side of the rear mirror support. Step 95. Tilt the rear mirror back down so that the rear mirror is facing forward at about a 70-degree angle. Step 96. Install an M4x14 screw through the computer side head frame adjustment slot and screw it into the back M4 nut of the rear mirror support. When this screw is loosened, back and forth tilt adjustment of the rear mirror is possible. Now we are going to install the top mirror, which is the shorter of the two. Step 97. Take the top mirror bezel and place it down onto a flat surface. Step 98. Take the top mirror, which is the smaller of the two mirrors, remove any protective film and place it down into the recess of the bezel so that it sits flush with the back sides of the bezel. Step 99. Place the top mirror bridge down onto the back of the mirror so that the ends of it line up with the raised portions of the bezel. Step 100. Insert 4 M4 nuts into the nut recess holes of the top mirror bridge and 1 M4 nut into the nut recess hole of the top mirror bezel. Step 101. Install 1 M4x14 screw through the back bolt recess hole of the bezel, the M4 hole of the bridge, and screw it into the M4 nut opposite it. Step 102. Install 1 M4x8 screw through the front bolt recess hole of the bezel, the M4 hole of the bridge, and screw it into the M4 nut opposite it. Step 103. Take the top mirror assembly and place it in between the top two sides of the head frame. Ensure that the holes of the head frame are aligned with the holes leading to the M4 nuts in the mirror bridge, and the side adjustment slot on the computer side of the robot head frame is lined up with the M4 nut in the bezel facing the rear of the robot. It is necessary to hold the top mirror assembly in place for the following step. Step 104. Install 2 M4x14 screws through the holes in each top frame piece, through the M4 holes of the top mirror bridge, and screw them into the M4 nuts opposite them, connecting the top mirror assembly and head frame. Step 105. Install an M4x14 screw through the computer side head frame adjustment slot and screw it into the back M4 nut of the top mirror bezel. With this screw loosened, tilt adjustment of the top mirror is possible. Now we are going to install the shell mounts, which are responsible for mounting the robot's external case. As this will involve using strong magnets, ensure that proper precautions, such as eye protection, and keeping the magnets away from electronic devices are taken. Step 106. Take 2 of the side shell mounts and insert 4 magnets into them, 2 in each. The magnet holes are designed to be a very snug fit in order to hold the magnets, so it may be necessary to use pliers to help press the magnets in. Step 107. Align the side shell mount bolt recess holes with the 2 remaining holes of the computer side post leading to the inserted M4 nuts. Step 108. Install 2 M4x8 screws through the bolt hole recesses of the side shell mounts, the M4 holes of the computer side post, and screw them into the M4 nuts opposite them. Step 109. Moving to the Arduino side post, repeat the process with the remaining 2 shell side mounts. Step 110. Take the remaining side shell mounts and insert 4 magnets into them, 2 in each. The magnet holes are designed to be a very snug fit in order to hold the magnets. Step 111. Align the side shell mount bolt recess holes with the 2 remaining holes of the Arduino side post leading to the inserted M4 nuts. Step 112. Install 2 M4x8 screws through the bolt hole recesses of the side shell mounts, the M4 holes of the Arduino side post, and screw them into the M4 nuts opposite them. Step 113. Take the 2 top shell mount pieces and become familiar with how they are installed. These mounts simply slot over the top of the head frame pieces and are not designed to be securely mounted due to the uniqueness of each robot case. If we would like to keep them in place once we have found the best position for them, we can tape or glue them to the head frame. Step 114. Install the remaining 4 magnets into the 2 top shell mounts. Although this is shown being done with the pieces installed on the robot, due to the snug nature of the magnet mounts, it may be necessary to install the magnets before placing the shell mounts on the head frame. The side ends of the top shell mounts are more delicate than the other pieces we have installed, and we should avoid putting any excess pressure on them. Congratulations! We have now completed assembly of the entire internal structure of the robot. This has been a big task, so a pat on the back and break has been well earned. Next, we are going to wire part of the robot and install the external case. In order to properly install the external case, it will be necessary to use a sharp object such as an X-Acto knife to cut out specific areas of the case before installation. Ensure to use caution when working with sharp objects, and be sure to use hand and eye protection. Step 115. Take the front case of the robot and place it onto a flat surface. Take note of the bottom section which sticks out past the lower curvature of the case, as we are going to be removing this. Step 116. Using a sharp object, slowly and carefully cut along the lower curvature of the case to separate the piece that is sticking out. It is important to go slow, and it may be helpful to tape the case to your work surface to keep it still. Keep in mind this bottom section of the robot will not be very visible, so if you do not make totally clean cuts, do not worry. Step 117. If your robot is from a newer production run, it may have a small flange around the bottom of either case piece. If your robot has this flange, you can choose to either cut it out or keep it installed. It is purely cosmetic and a personal decision. Step 118. Lift the front case up and place it over the robot's internal structure as shown in the video. We are now going to make a decision about the sound level sensors. The sound level sensors provide the robot with the ability to turn its head to face the direction of sound, such as us speaking to it. The sound level sensors are not necessary for the head movement system, as we can program it to run on a loop without reacting to sound. The decision whether to keep the sound sensors in place is up to you. For these instructions, we will continue as if we are going to use the sound sensors. Step 119. With the front case flush against the sound sensors, we will be able to see through to the relative position of them. Using our sharp object, we are going to cut a hole around the location of each individual sound sensor so that it can stick out of the front case a bit, unobstructed from properly detecting sound. Step 120. With the front case positioned over the front half of the internal structure, take two of the magnets and place them on top of the case, over the front top shell mount. The magnets will snap into place on their own when near the opposing magnets of the shell mount, as they are very powerful. Step 121. Using the same principle, take two magnets and place them over the front case across from the Arduino side front shell mount. Step 122. On the opposite side, take two magnets and place them over the front case across from the computer side front shell mount. We are now going to outline the proper way to wire all of the electric components together, sans the Arduino, which has its own dedicated instructional section. Step 123. Take the power cable for the computer and install it into the power jack on the back of the computer. Step 124. Take the USB-A to USB-B cable and plug the correct side into the back computer USB port and the other into the Arduino USB port. Step 125. Take the short HDMI cable and plug one end into the computer's HDMI port and the other end into the angled HDMI adapter sticking out of the bottom of the projector. If your angled adapter is facing the opposite side of what is shown in the video, the install process is still the same. Just route the short HDMI cable to the other side to plug it into the adapter. This can be a tricky one to get, so be patient and feel free to remove the front case to get more room. Step 126. The included microphone is designed to be used externally and does not have any specific install instructions, other than plugging the end of it into the top USB port of the computer. The microphone cable can be run down the side and underneath the external case curvature, so that we can pull the microphone further towards us when speaking to the robot. Step 127. Install the small zip tie over the power cables by placing it through the two holes on the base plate and tightening it over the top of the cables. Step 128. Take the rear case and place it on a flat surface. Step 129. Using a sharp object, slowly and carefully cut along the lower curvature of the case to separate the piece that is sticking out. It is important to go slow, and it may be helpful to tape the case to your work surface to keep it still. Keep in mind this bottom section of the robot will not be very visible, so if you do not make totally clean cuts, do not worry. Step 130. Using the sharp object, cut out the rectangular-shaped indent on the bottom center of the case. This is the hole for the power cables of the robot to be run through so it can be removed and discarded. Step 131. Take the rear case and place it over the back half of the robot's internal structure. Step 132. With the rear case positioned over the back half of the internal structure, take two of the magnets and place them on top of the case, over the rear top shell mount. The magnets will snap into place on their own when near the opposing magnets of the shell mount, as they are very powerful. Step 133. Using the same principle, take two magnets and place them over the rear case across from the Arduino side back shell mount. Step 134. On the opposite side, take two magnets and place them over the back case across from the computer side back shell mount. Congratulations! The robot has now been completely built and is ready to spring to life and become an intelligent AI-powered educational companion.